with a piece out of the book instead of our homework. Homework tonight is going to be 85 and 86. We're starting on page 78. We do have a definition to start with, so go ahead and pull out your highlighters / markers. We have a composite figure, which is what we're going to be talking about today. A composite figure is a figure made up of more than one geometric figure.
We're in the middle of instruction. Oh my gosh, really friendly.
Okay, I will say I am still highly disappointed at the number of you that are not doing the basic things we have asked you to do that are going to help you out immensely. Stuff like, Alina, marking the text. Guys, you're not going to understand this if you don't understand what's being asked. That whole point of doing the directions test. You got to understand what you need to do in order to do it. And that happens by marking your text. So we need to show how you can decompose each figure into 2 or more familiar figures. Describe the shapes that make up the composite figure. And they gave us our definition. So we need 2 parts. Show how to decompose it and describe the shapes. I will be straight up with you guys. For me as a teacher, this is literally the hardest lesson of the entire year. This is the hardest lesson for me for the entire year. Because unfortunately, I have to depend on you. There's really nothing I can do except hope that you have done the work so far and that you are able to apply what we have taught you. Because that's what needs to happen. Now's not a good time, Carter, sorry. So, what we need to do is we need to look at the figure, break it into shapes that we know. I'll give you a hint. These are all on your formula sheet. So that formula sheet we gave you and told you is your best friend, again, we're pulling it out because this is what we need to break it into. So when I look at a composite figure, which is made up of familiar shapes, those familiar shapes we're looking for are stuff like parallelograms, triangles, rectangles, squares, the things that we have formulas for. I don't have a formula for the shape that we have right here in shape A. There's no formula for that. So I have to break the figure into smaller pieces to figure out the area using shapes that I do know the formulas for. So that being said, who can tell me how did you break up A? Samila? Which way? Up and down. That's the most common, is going like this. So you end up with 3 rectangles. How many of you did it that way? About half, not bad. So what was another way that someone did it? Riker?
The top where the line goes down.
Okay, so you basically just went this way. So you also did 3 rectangles, it's just 3 different ones. Is that also correct? Which is, again, part of the problem for me in teaching this. There are multiple correct ways to do this. How did you do 4? Divide it in half? Like here? Okay, would that work? Yeah? That's fine. Now I will tell you, and you'll see this in just a little bit, one of the keys in this is you have to use the information they've given you to find shapes that you can find the measurements of. Okay? You got another way?
Yeah. In the middle, you got a line in the middle.
But do you know how to find the area of this shape?
So you did one like this? The problem with that is, do we have a formula for this shape? Nope. So that's not a familiar figure. Familiar figures are the ones that we have shape formulas for. So although you can do that, that actually doesn't help us because I can't find those areas. Make sense? So again, the one big parameter on these composite figures, guys, you have to draw a shape that you know the formula for. Okay? What about for part B? Someone give me an answer on that one. Interesting. Okay. So you kind of went to the next section on that one. So what she showed me, guys, is she actually added a triangle. That's actually what we call composing, not decomposing. So that'll work for the second part. but not for our first part. Okay? And unfortunately, with what she drew on the other part of it, it won't work the way she has it. Yes? Okay, so where were your 3 rectangles?
One on the right side.
So here?
Yeah. And one coming down.
Okay? Like that? Okay, so he has 3 rectangles and a triangle. Does that work? Yeah, that's fine. Yes?
The middle part from that one right there, that's not rectangle. That mostly looks like a square.
It would be close. Without the actual measurements, I won't know exactly, but that still to me looks like that's going to be longer than this side is. So it's probably still a rectangle, but honestly, rectangle and square, it's the same formula. I'm just multiplying those 2 sides. Yes? Okay, so which one did you cut? This one or this one? So this one? Like that? Okay, would that work? Yep, so she just had 3 of them. So she did 1, 2, 3. So she has 2 rectangles and a triangle. Does that work? Now, quick note, could I have just done this? Number 1's a trapezoid. Do I have a formula for that? Number 2 is a rectangle. Do I have a formula for that? So I could have done that, right? I also could have gone this way and just done 2, a rectangle and a trapezoid. Correct? Or I could have gone that way and done 2 rectangles and a triangle. Guys, all these are right answers, okay? And that's, again, part of what makes this hard. There are a bunch of right answers, but it's got to be the way you see it, but you have to break it down and you have to show your work, okay? Now, the second part, show how you could compose each figure into a larger familiar figure, and again, describe the shapes. I didn't write those ones down, so I'll use this one, and this one we would have said 2 rectangles and 1 triangle, right? Make sense? Okay. Number 2. This is how I would solve it, especially this first one. I would actually make it into one big rectangle, and then I would take away this little piece. To me, because it's 2 steps, that makes it super easy. So what 2 shapes? 2 rectangles. Part B, to compose it, I'm going to add this piece in. Now, one thing on the composing, again, this to me makes this one easier because I now have a big rectangle, and then I'm going to subtract the triangle. So 1 rectangle. Okay. Hopefully they didn't pick that one up on the recording. Okay, 1 rectangle, 1 triangle. Yes?
I also have another one.
What's that?
Since like you fill in that spot with the triangle, it could also be 1 square.
If the sides are the same, again, to me the base looks longer than the height. But yeah, if you said square or rectangle on that, I would take it. Yes?
I did that same thing.
Good.
I added the corner piece, but then instead of making those 2 I made it into 4 by drawing 2 pieces.
Okay, the only part on that is you're decomposing, and the instructions were compose. Because believe it or not, first period, I actually was showing this way, and Miss McSham pointed out that it said decompose, and she's like, "You're wrong, Mr. Moore," and I actually had to admit I was wrong. It was really sad. Okay? Does everybody kind of understand the concepts here?
Yes.
Okay, I hope so, because now we're going to give you a chance to practice it. Let's go ahead and go to page 79. Okay, on this one, consider the blueprint for our floor plan of a kitchen, dining room, and living room combination. Suppose the homeowner wants to replace the floors in all the rooms. Wanda says she can determine the total area of the flooring needed by decomposing the blueprint into 2 rectangles. Naveed says he can determine the total area of the flooring needed by composing the blueprint into one large rectangle and subtracting the unused area. Who is correct? So there's our question. So in our modules, you may have noticed 3 things by now. I think this is the first one I've really seen this one. Normally it's either a thumbs up, they're right, or a thumbs down, they're wrong. You have to say why. This one, you actually need to tell me who's right. So, is Wanda right? Is Naveed right? Are they both right? Or are they both wrong? So look at what they said, make a determination, and go ahead and write down what you think the correct answer is as to who is correct. I'll give you about 2 minutes to think about this one, because it's literally just one of those 4 options that you need to choose. Appreciate that. Secondly, let's take a vote. Who thinks that only Wanda was correct? 4 of you? Wanda, but only Wanda. Okay, hands down, how many think only Naveed was correct? Good. You're getting some variety. How many think that both of them were correct? Interesting. How many think both of them were wrong? Good. So everybody saw that at least one of the methods worked. So Wanda's saying I need to put 2 of them together. So she's saying, could I do like one big rectangle here and one here? Would that work? That would work, right? She could also have gone this way, and then she'd have 2, correct? Would that work? Good. For Naveed's, what he was really saying is, I'm going to make it a big rectangle, and then I'm just going to take this part out. So you're going to have a whole big one, and take out number 2. Does that work? That would also work, right? So, actually, most of you are correct. They are both correct. Now, that's an interesting point. I'm not sure who said it behind me, but someone said one of those is easier. In this case, I would actually argue they're actually the same.
Yeah.
Because you're doing 2 steps in either one. There are times where one will be considerably easier than the other. This isn't one of them. So this one is literally just what one do you prefer. So now, let's get down to the next part. Show how to calculate the amount of flooring needed using Wanda's method, and show how to calculate the amount of flooring using Naveed's method. Except I'm going to say, instead of just show, I want you to calculate the amount of flooring needed with each of those 2 methods. Okay? So Wanda, I showed you 2 ways she could have done it. Naveed, there's really only one. So do both of them. See if you can figure out how to calculate the amount of flooring. We'll give you guys about 5 minutes, and we'll let you work quietly as a table on this one if you want. Yes, Logan? Guys, quiet. We should have a question. Uh-huh.
I did like a different method. I did like a square.
Okay, I'm going to come talk to you in just a second. Everybody else go. Okay, on this one, I'm going to use the first version that I showed for Wanda. So I'm going to say that's 1, and this is 2. Guys, one key on these composite figures. As you break the composite figure up, please label it and show all your work so that we know Ms. McShannon and I can look at your paper and understand what you did. So if I have it labeled like this, it makes it very simple, because once I've got it labeled into the figures I know, now you're literally just following the algorithm we gave you for the individual shapes. Okay? So for shape 1, what shape is that? Rectangle. So I know for 1, I start with my base formula, length times width. I go to my picture, I label the length and the width. For number 1, what's my length, what's my width? Alina?
Your length is
15? 15? And my width is? Is she correct?
Yes.
Honestly, I would have done it the other way, but does it really matter? No, as long as I've got a length and a width labeled that are the length and the width, because I'm multiplying them, commutative property of multiplication says I'll get the same answer. Okay? So she said area is the length of 15 and a width of 30. So I multiply those together and I get 450 square feet. Number 2 is the smaller rectangle. So what's my length and width on this one? Good. Is the length She's saying 12 is the width. Again, I would have done it backwards, but as long as you correctly have the two labeled, you're good. So we say length of 10, start with our base formula, length times width. Area equals 10 feet times 12 feet, right? Or 120 square feet. Now, here's the last step in composite figures, and this is the most difficult part, believe it or not. And it's, how did you see it? Am I composing or am I decomposing? If I'm composing, I'm going to put them together, so I'm adding. She's composing. She said 1, 2, I'm going to put them together. So I'm going to add those two. 450 plus 120 gives me 570. So my total area equals 570 square feet. Make sure you put the exponent in the right spot. Okay? Now let's look at using Naveed's method. Naveed said, okay, I've got the one is the same, but it's now this whole big one. My second is just this little bitty one. So for him, my big rectangle is going to be length times width. So on that big rectangle, what's my length, what's my width? Ben? Where'd you get 25?
Just explain it. Don't let it mess with your head.
But that's so much more fun.
I know.
Ben, where did you get 25?
15 and 10.
Good. He said on this side, I know that's 15 and that's 10, which gives me 25. Make sense? So I'm just going to keep the W, meaning this is now our length. So I have a width of 30, a length of 25. So I go back to my formula, and now I put the numbers in. 30 feet times 25 feet gives me 750 square feet. My second one is now this little rectangle. I can see that 10 is the height, but what about that width? I don't know that, do I? So how do I use the information they've given me to figure it out? What do you think, Riker?
Because on the top's 30. And
Okay.
down on the bottom left is 12. We did 12 minus 30. Then that's the leftover.
Which is?
Oh. 18.
18. Okay. How did he do it? He said the whole thing is 30. I know that far is 12, so the rest of it must be 18. So I now have my length and my width for the small made-up rectangle. So I now A equals LW. I have a length of 18, a width of 10, right? Yes. So that gives me 180 square feet. Here's where you gotta again go back and think. So I did the whole big figure, but this part's not part of it. So what am I gonna do to those two numbers? Milo? Times? No. Subtract. Because this isn't actually part of what I need, is it? So I need to pull that out. My mathematical operation for that is subtraction. So I'm going to take 750 minus 180 gives me 570. So, did it matter which way I did it? No. And if you don't make a math error, it shouldn't matter. So that's a whole big piece of this, guys, is you have to do what is comfortable for you. However you see it. If you see it composing, do that. If you see it decomposing, do that. As long as your math is correct, you'll be able to find the right answer. The one caveat, the one restriction I'll place on that, you have to be able to find the numbers based on the information they gave you for how you're breaking it up. So if the way you're breaking it up, there's a number you can't find, you're going to have to look at it in a different way. Okay? And the reason I say that, I'm just going to give you guys a quick example. Going back to this picture, as I was checking my side, I actually had a couple of students who said, I saw that as 3 triangles. Does that work? It does work. Here's the problem. The chances that they're going to give me that measurement, the height for that triangle, are about 0. Meaning that you could break it up that way, but I can't actually calculate the area because they didn't give me the information I need for that triangle. So you'd have to look at it in one of the ways we did in order to break it down and actually solve. Ben? You can't because, again, you don't know this. You technically could use Pythagorean theorem, but only if they went to there, and we have no information on that piece. So depending on what information they gave us, there is a potential you could calculate it, but it's an exceptionally small potential. Okay? So we looked at those. Does everybody understand? Doesn't matter, I can get the same answer, yes?
Yes, sir.
Okay. So now we're going to let's set you free. Suppose that carpeting costs $1.20 per square foot. How much would it cost to carpet every room in this house except the kitchen? So there's my task. So I'm going to need to break this down. Guys, pay attention. So what you're going to need to do is calculate my area, but I don't want that. Okay? So there are a couple different ways to do this. I'll give you a hint. The way I've done it and done it successfully is having 4 shapes. Remember, you have to have a shape you have a formula for. Okay? We'll give you guys about 7-8 minutes to try to knock this one out. So I'm just showing the way I did it. You may have done it differently, but you should come to the same area if you do the math correctly. So for me, I said this works out pretty well because I've got 3 pretty easy ones, right? 1, 2. The problem is this third of the living room isn't a familiar shape. I don't have anything for that kind of a shape. So for the living room, I'm going to cut it into 2 parts. So that's going to be my 3 and 4. Make sense?
Guys, you could have divided it the other way as well.
Yep. Okay. Now the key is I now have to use the information they've given me to figure out the missing pieces of my picture. Because there are several missing pieces. The first missing piece is pretty big. That's how far is this distance. But that one's easy, right? I know it's 10 to here, another 10 to here, and then another 5 to get to here. So what's the total from here to here? 25. I know from here to here is 8, and the whole thing is 25 because it's like a big rectangle. So what would this distance be then? 17. Does everybody see that one? That's the easy one. Okay, now the hard ones are actually on my small number 3 here. So let's think about it. From here to here was 10. From here to here is 14. So how far was this little piece that's in between? 4 feet. I know from here to here is 17, yes? I know from here to here is 10. Here to here is 10. So going up to here would be 20. So I know going all the way up to here is going to be how far? 20. Everybody good so far? Okay. I also know this is 5 feet. This whole thing is 8 feet. So that means this little piece is how far? 5 feet, 8 feet. The whole distance here is 8, yes? Same as this. This part of the distance is 5. So this part of the distance is going to be 3. Because 5 plus 3 is 8. Everybody see that? Okay. I know that this part is 3. I know the whole thing is 10. So how much is this part? 7. Because 7 plus 3 is 10. So I now have the dimensions for all of my figures. Figure 1 is my enclosed porch. Area is length times width. Technically it's side squared because this is a square. So I know my length is 10, my width is 10. So area equals 10 feet times 10 feet, or 100 square feet. So that's number 1. Number 2 is my dining room. This one. Oh, we haven't done this one yet, have we? Okay. I know this is 35. We figured out that this part is 4, yes? This part is 12 because it's the other side of this, meaning this part is 16, yes? So then what's the second part going to be? Logan? 19. So this one is 19 feet. Does anybody not see how we got to the 19? Okay. So number 2, I know it's another rectangle, so it's length times width. So I'm going to do a length of 19, a width of 8. So 19 feet times 8 feet. 19 times 8 gives me 72, 152 square feet for the second part. Number 3, that's my little one right here. So we said this one, again, is a rectangle, length times width. I'm going to do a width of 7, a length of 4. So area equals 4 feet times 7 feet, or 28 square feet. And number 4, that's the dining room. Or no, that's the living room, sorry, or what's left of it. I know that I have a length of 12 and a width of 17. So area is length times width. I now know that is 12 feet times 17 feet. So do that math. 12 times 17 gives us 1484. 12, 4, 10, 204. But now is where I got to step back and say, did I compose or decompose? Did I break it into smaller shapes? Or did I look at a bigger one and take pieces out? A decompose, meaning to make it together, I now need to add them. Does that make sense to everybody? Because I found all the little pieces. Now to find my whole area, I got to put it back together. So I'm going to add them. So I've got them all. I'm going to take the 204 plus 28 plus 152 plus 100. And I'm just going to add those numbers. So that's going to be 10, 14, 7 and 1 is 8, 2 and 2 is 4. So my total area equals 484 square feet. Good. So how many were able to get that?
Well, wait, what about the 1,000?
I had 2 people in the entire room get it.
Oh, I did.
Let's try this again. How many got 484 square feet? Raise your hand high enough that I can see it. 1, 2, 3 of you? Nobody on my side? Not a single one. Okay. How many of you wrote that as your final answer?
484?
Yeah. That's your final answer?
That's my final answer.
Hannah, that's not your final answer? Oh, it is your final answer. Yes? Guys, again, you gotta pay attention. What did the directions ask for? How much it would cost. Have I found out yet how much it would cost?
No.
No. So I have to take the 484, I'm going to multiply it by $1.20. So I'm now going to take this times 120. So I have 2 decimal places. So now I'm just multiplying 484 times 120. Gives me 0. 2 times 4 is 8. 2 times 8 is 16. 2 times 4 is 8 plus 1 is 9. 2 zeros and then 484. Now I add it. 0, 8, 10, 18, 5. I put the 2 decimal places into my answer. So our final answer should have been the total cost. No, you raised your hand last time and said your final answer was 484. You can't change your mind at that point. Okay, so the total cost. Guys, this is the type of problem we are going to be giving to you at some point in the next 2 weeks.
Are you serious?
Serious. That will be going all the way to Dodia headquarters.
Yes.
So,
No, don't play.
you have to understand how to do these multi-step problems. So, the good news is I showed you how to do a harder one. We're now going to give you an easier one to see if you can redo this. Suppose a gallon of paint covers about 400 square feet. How much paint would you need to paint the entire back of this house? So there's our task. I'm going to add a couple caveats. They've shown you the front of the house. The back is completely blank. There's no windows, no doors, nothing. So you get to paint the entire back side of the house. So you don't have to worry about taking anything out. They've given you the shape. You now need to break the shape down, figure out what your total square feet would be. Okay? We'll give you guys about 6 minutes. You may work together quietly as a table on this one.
This one is easier to like it.
Guys, you're on recording. Okay, I got to go quickly because we're almost out of time. So I'm going to show you how I personally would have seen this and done it. I saw this as 3 shapes. I see a triangle and 2 rectangles. So I'm going to start with number 1. Remember, start with your base formula. It's a triangle, so it's 1/2 the base and the height. I know my height is 10, so there's h, but I don't know my base yet, do I? No, but what I do know, and this is where they're going to give you enough information to figure it out but not give it to you, is examples like this. I know from this point to this point is 50. I know from this point to this point is 18, which means that the part in between has to be 32. Because 32 plus 18 gets me to 50. Make sense? If you don't know it, you subtract. 50 minus 18 will get you to 32. Well, this, because this is a rectangle, means my base here is also 32. So now I can put my numbers in the formula. 1/2 of the 32 times the 10. I love multiplying by 10, so I'm going to take 1/2 of the 32 and make that a 16. 16 times 10 gives me 160 square feet. So there's number 1. Number 2, this is this rectangle here. So I need area is length times width. I know I have a length of 32. I've already did that. The width is 12. So 32 feet times 12 feet. So I'll do this one over here. 32 times 12. 4, 6. 32 gives me 384. So my area is 384 square feet. And shape 3, they gave me both of those. So I know I have a length of 18, a width of 9. Area equals my length times the width, or 18 feet times 9 feet. Do 18 times 9 gives me 72, 162. In order to find my total area, I decomposed it, so I'm going to put them back together. So 162 plus 384 plus 160 gives me 6, 12, 20, 3, 4, 5, 6, 7. So I have a total area
You should have this on your paper.
of 706 square feet. Am I done? Why not, Hannah? Good, because the question is how much paint do I need? I know 1 gallon covers 400. I've got 700, so how many gallons am I going to need? 2. So we're going to just use estimates on this one. It didn't ask for exact. So I will need 2 gallons of paint. So you could have done all that work and not answered the question and you still get it wrong, right? Questions on those? Okay, we've only got like 3 minutes left, so I'm going to have to fly through this one. I want you to go to page 81.
Guys, quit talking and listen. This is going to go fast.
We're going to go on number 5. Now, this is often going to happen. They're going to ask you to find a shaded area within a frame. These are all going to be composing pieces. So I've got the big piece. I'm going to have to take pieces out to figure out what I don't know. This one, I see a big square, and I have triangles inside of it. I've got 1, 2, 3, 4 triangles that are identical, right? They're all 6 by 3. What you may not see, I've also got these little ones on the side, right? If that's 3 and that's 3, what's my base? 6. If I put those two together, if I slide this over here, this now has a base of 6, which is identical to this. Same thing here. If I slid this over here, I have another one. So I actually have 6 of the exact same triangles that I'm pulling out. So here's what your math looks like. Number 1 is the big square. Length times W. I need to add them all together. That's 12. That's 12. Okay. Guys, the rest will be on the video. So I do highly recommend, because I'll give tips on the homework tonight as well. Take your homework, 85, 86. Okay, so just to finish this one out, because the kids are all gone now. Number 2 is going to be our triangle shapes. So we start with our base formula, 1/2 the base times the height. All of our triangles are the same. They have this base of 6 and the height of 3. So I put those numbers in. Area equals 1/2, my base of 6, my height of 3. And Mr. Moore, remember, do the even one. So I'm going to do 1/2 of 6 is 3. 3 times 3 gives me 9. But that's one triangle. And as we just talked about, we actually have 1, 2, 3, 4, 5, 6 of them. So I'm going to take that times 6 to give me 54 square centimeters. I take that from the overall area, 144, minus the 54 gives me 90. So the shaded area equals 90 square centimeters. Unfortunately, you really don't have any other way to do this one, because I don't have a formula for this type of a shape, and I can't really get measurements for these. They did not give me any of these diagonal ones. If they'd have given me those, I could break it up into shapes or rectangles, but without those, this is really the only way to solve this type of problem. Okay, going to the homework, which is why I'm assuming most of you would probably listen today. Let's go over this, starting on page 85. First off, define the composite figure and draw a picture of an example. So not only do you need to define it, but also draw one. Our practice, calculate the area of each composite figure. So they've given you several of them. I'll give you a couple hints. It's on the video. I would break this into a rectangle and a triangle. On part B, you actually have several options on this one. Given the measurements that they've given us, I would probably go with a trapezoid. I would probably go like this. A rectangle, and a trapezoid. But there's a couple other ways. If you'd rather work that in a different way, you can as well. This isn't a bad decomposing one, or a composing one, because I could draw that one out, and they've given me this height, because I know 4 and 3, so I know what's left of the 11, and I know this is the same as this, so that gives me my base and my height for that triangle. So I would need to add that triangle to the other shapes. Or I could actually take this one and this one out of the big one, 11 by 6. So lots of different ways you can do that one. This was the most missed on last year. The city wants to create a garden according to the plan shown. Calculate the area of the garden. There's our task. And on this one, probably easiest, this little triangle right here caused a lot of issues. One thing we could do is we could do a trapezoid here, because I know that this base would be 5. I know that this base, if I took the 4 away from the 12, would be 8. And I know that my height is 4. I could then do a rectangle here. And then I could do either an additional trapezoid on this side, or I could break this into another rectangle and a square. So up to you if you did that in 2 or 3 spots. So there's a pretty easy way to knock that one out. The figure shown is composed of a rectangle and a hexagon. The length of each side of the hexagon is 2 centimeters. So that's one that they've given you now. Determine the area of the shaded region. There's our key. This is going to be another composing, so we use the big one. Remember, when I do a mixed number, I need to slam dunk first. For the inside, you could actually just make this really simple. I know that that now gives me 4 centimeters as a base, 2 centimeters as a second base, so I can make this 2 identical trapezoids. 3.5, basically I have to divide that in 2. So 7/2 divided by 2 is going to be 7/4 for my height. So I'm giving you a couple good bonuses. And your number 2 is actually the same. So if you figure this one out, you can double it and then take it away from the entire rectangle. Our last one, the figure shown is composed of a triangle within a trapezoid. Determine the area of the shaded region. So there's our task. Again, we're looking at the shaded region. So this one, really only one way to do this. Do the big trapezoid, do the triangle, and subtract it. So you subtract the triangle from the first area. Stretches, kind of cool. Do them if you can, would be great. They actually made this really easy for you if you look at it though, because number 2 looks like, oh, they didn't give you the perpendicular distance. Yeah, so I can't do the parallelogram formula because they didn't give me that line. So you are going to have to break it into smaller pieces if you want to do that one. Good luck, guys. Let us know if you have any questions. You can come in at seminar.